Ever looked up at the sun and just seen a big friendly ball of light? Well, what if I told you that same sun could plunge our entire world into darkness? Not for a day, but for weeks, months, or even years. Sounds like a sci-fi movie, right? But the threat is very real, and it's called a solar storm. Imagine waking up one morning. Your phone is dead. The lights won't turn on. The fridge is silent. You look outside, and it's the same for everyone. No internet, no TV, no running water, no way to buy food or fuel. This isn't a local power cut. It's a global blackout. And it's all because of a massive burst of energy from our own star, 93 million miles away. Today we're going to explore this incredible cosmic threat. We'll dive into the science of space weather, understand what a solar storm really is, and ask the big question: could a solar storm really cause a massive, civilization-altering blackout on Earth? Stick around, because the answers might just change the way you see that bright, warm sun. So, what exactly is a solar storm? To understand it, we need a quick trip to the heart of our solar system. The sun isn't a calm, steady fire. It's a churning, boiling ball of plasma with an incredibly powerful and complex magnetic field. Think of it like a tangled mess of cosmic rubber bands. Sometimes these magnetic field lines get so twisted and tangled that they snap and realign, releasing an unbelievable amount of energy. This can happen in two main ways that affect us here on Earth. First, you have solar flares. These are intense bursts of radiation. If a strong one is aimed at Earth, it can travel at the speed of light, reaching us in just over 8 minutes. These flares can disrupt radio communications and GPS signals, which is a major problem for airplanes and ships that rely on them for navigation. But the real heavyweight contender, the one that keeps scientists up at night, is something called a coronal mass ejection, or CME. A CME is a colossal eruption of plasma and magnetic field from the sun's outer atmosphere, the corona. We're talking about billions of tons of solar material hurtling through space at millions of miles per hour. It's like a cosmic cannonball being fired across the solar system. If Earth happens to be in the crosshairs, this cloud of charged particles will slam into our planet's magnetic field a few days after the eruption. This collision is what creates the beautiful auroras, the northern and southern lights. But it can also have a much, much darker side. Our planet's magnetic field, the magnetosphere, acts like a protective shield. It deflects most of this harmful solar wind, but a powerful CME can distort and compress this shield, inducing massive electrical currents not just in space but right here on the ground. And this is where our modern way of life becomes incredibly vulnerable. Our power grids, with their thousands of miles of long transmission lines, essentially act like giant antennas. These geomagnetically induced currents, or GICs, can flow into our power grid through these lines. The problem is, our electrical transformers, the workhorses of the grid that step voltage up or down, are designed for alternating current, AC. These induced currents from the sun are more like direct current, DC. When this DC-like current flows into a transformer, it can cause it to saturate. This saturation leads to extreme overheating in a matter of minutes. The transformer can physically melt down, warp, or even explode, causing catastrophic damage. Now you might be thinking, okay, so one transformer blows. We can just replace it, right? Well, it's not that simple. We're not talking about one or two transformers. A powerful solar storm could simultaneously damage hundreds of high-voltage transformers across an entire continent. These aren't items you can just pick up at the local hardware store. They are massive, weighing hundreds of tons, custom-built, and can take months or even years to manufacture and install. If a significant number of them are knocked out at once, we simply don't have enough spares to fix the grid quickly. The supply chain would be overwhelmed. This is the nightmare scenario, a widespread, long-duration blackout. Has this ever happened before? Yes, it has. The most famous event is the Carrington event of 1859. A massive solar storm hit Earth, and the world was a very different place. The most advanced technology was the telegraph. The storm was so powerful that it induced currents strong enough to set telegraph offices on fire and give operators electric shocks. Some telegraph systems even continued working for a while after being disconnected from their power supplies, running solely on the energy from the solar storm itself. The auroras were so bright that people in the Caribbean could read newspapers by their light at midnight. If a storm of that magnitude were to hit us today, the consequences would be unimaginable. A 2013 report from Lloyd's of London estimated that a Carrington-level event could leave 20 to 40 million people in the U.S. without power for up to 2 years, with a total economic cost in the trillions of dollars. Think about it. No power means no clean water purification, no sewage systems, no refrigeration for food and medicine, no banking, no communications, no fuel pumps. Society as we know it would grind to a halt. It would be a true survival situation, not just for a few days, but potentially for years as we struggle to rebuild the backbone of our civilization. And don't think this is a 1 in a million chance. In July 2012, a CME of Carrington-class intensity erupted from the Sun and tore through Earth's orbit. Luckily for us, Earth had passed through that exact spot just 1 week earlier. We dodged a cosmic bullet by a hair's breadth. NASA physicist Daniel Baker said, "If it had hit, we would still be picking up the pieces." So the question isn't if another major solar storm will happen, but when. So what can we do? Are we just sitting ducks waiting for the sky to fall? Not entirely. The first line of defense is prediction. We have a fleet of satellites like the Solar and Heliospheric Observatory, SOHO, and the Solar Dynamics Observatory, SDO, that constantly monitor the Sun. These give us an early warning, typically a 1 to 3 day heads up for a CME. This warning is crucial. It gives power grid operators time to prepare. They can take preventative measures like reducing the load on the grid, redirecting power flows, and even taking certain vulnerable transformers offline temporarily to protect them. It's like battening down the hatches before a hurricane. On a longer-term scale, we need to harden our infrastructure. This involves developing and installing new types of transformers that are more resilient to these DC currents. There are also devices called neutral blocking capacitors that can be installed to block the flow of GICs into transformers. Some countries and regions are taking this more seriously than others, but it's a huge and expensive undertaking to upgrade an entire nation's grid. The investment, however, pales in comparison to the potential cost of inaction. So to answer our original question, will a solar storm cause a massive blackout on Earth? The potential is absolutely there. A direct hit from a Carrington-level event could be the most devastating natural disaster our modern world has ever faced. However, it's not a certainty that we be thrown back to the Stone Age. Thanks to our space weather forecasting and the growing awareness among grid operators, we have a fighting chance to mitigate the worst of the damage. We can protect key assets and manage the grid to prevent a complete collapse. But the race is on. Our Sun operates on an 11-year cycle of activity, and we are currently heading towards a solar maximum, expected around 2025, where these events become much more frequent. We need to continue investing in our space weather prediction capabilities and urgently upgrade our power grid infrastructure. It's a global challenge that requires cooperation between scientists, engineers, and governments. The Sun gives us life, warmth, and energy, but it also commands our respect. Understanding its power and preparing for its fury is one of the most critical tasks for ensuring the resilience of our technological society. So, next time you feel the sun on your face, remember the incredible power it holds. It's a beautiful, life-giving star, but also a volatile and potentially destructive one. The threat is real, but so is our ability to innovate and prepare. Thank you so much for joining me on this deep dive into the power of solar storms. If you found this fascinating and want to learn more about our amazing and sometimes scary universe, please hit that like button and subscribe to the channel. Let me know in the comments what you think. Are we prepared enough for the next big one? Stay curious, and I'll see you in the next video.